Welcome, and thank you for joining me. Today's talk From Prompts to Problems explores how generative AI, especially ChatGPT, is changing how we approach questioning and problem design in STEM education. We'll look at what happens cognitively when students use AI. It influences their strategies, planning, transfer of knowledge, and mental load. I'll also share research findings and a classroom example to ground the theory in practice. Ultimately, we'll ask how can we use AI not just to solve problems faster, but to help students think more deeply. Generative AI, especially ChatGPT, is reshaping STEM education by enabling fast, flexible problem creation and personalized learning. Teachers can quickly generate diverse, real-world math and science problems that match different levels and learning styles. Students can also use ChatGPT as a questioning partner, asking for hints, clarifications, or even rewording a problem. Crucially, AI can scaffold complex thinking. It offers step-by-step guidance, alternative strategies, and contextual prompts, making abstract concepts more accessible. But the goal isn't just efficiency. When integrated with intention, generative AI supports rich inquiry, helping students not only solve problems, but think critically about them. In STEM education, generative AI, like ChatGPT, supports both teachers and students by making problem design faster, more adaptive, and more engaging. It helps teachers generate authentic problems in seconds, from basic drills to complex real-world scenarios. It also supports differentiation, adapting task difficulty and format for diverse learners. For students, AI becomes an interactive partner. It offers hints, alternative strategies, or step-by-step breakdowns when they race stuck, providing guidance without giving away answers. AI also boosts efficiency, more iterations, more variety, less busy work. This frees students to focus on reasoning, and teachers to focus on feedback. Used well, AI doesn't replace inquiry, it accelerates it. But to deepen learning, it must be paired with intentional design and thoughtful student interaction. Cognitive strategies are the methods students use to understand and solve problems, like breaking a task into steps or trying different approaches. ChatGPT can model these strategies by showing multiple ways to solve a problem. Students learn not just from the final answer, but by comparing methods and reflecting on their reasoning. In studies, students reported that AI-generated solutions helped them think more creatively and flexibly. But the key is guidance. If students rely too much on AI, they may stop thinking for themselves. So we must use AI as a thinking partner, not a shortcut, to help students build strong, transferable problem-solving habits. Planning and monitoring are core metacognitive skills. Students need to plan how to solve a problem and track their own understanding along the way. ChatGPT can support this by helping students outline steps or double-check their reasoning. When used intentionally, it acts like a mirror, making students pause, reflect, and revise. Research shows that students who explain concepts to AI or critique its answers become better at regulating their own learning. But again, it's not automatic. We need to teach students to question AI, not just accept it, so they stay in control of their thinking. Transfer is the ability to apply knowledge in new situations, a key goal in STEM learning. ChatGPT supports this by showing how a concept can appear in different contexts in science, finance, or daily life. That variety helps students see the underlying principle. More importantly, we can ask students to adapt AI-generated problems or create new ones, turning them into active designers, not just problem solvers. When students reframe or extend problems, they internalize the concept more deeply. That's how we move from understanding to flexible, real-world application. Cognitive load refers to the mental effort required to learn. If a task feels overwhelming, students can get stuck. ChatGPT can help manage that load. It can simplify wording, explain steps, or retrieve facts so students can focus on the core ideas. But there's a risk if AI does too much. Students may skip the productive struggle that builds real understanding. Our role is to strike the right balance using AI to reduce distractions while keeping the thinking in the student's hands. Here's how this works in the classroom. Students are given a multi-step math word problem, but instead of jumping straight to solving it, they first ask ChatGPT, "How would you solve this step by step?" ChatGPT replies with a full explanation clarifying the problem, defining variables, and showing the process. This helps students see how an expert might approach the task, but they are not copying the answer, they are using it as a model to reflect on and improve their own thinking. It's a first step that sets up deeper engagement in the next phase, analyzing and critiquing. In the second phase, students analyze ChatGPT's solution step by step. They label each step as correct, incorrect, or unclear and explain why. This process activates meta-cognition. Students must justify their reasoning, question assumptions, and identify gaps in understanding. Even when the AI is mostly correct, students often find places to revise or improve the solution. That critical examination is where deeper learning happens. The goal isn't to catch the AI, but to help students make their thinking visible and strengthen their ability to evaluate mathematical reasoning. Next, students compare their analyses in small groups. They share which steps they marked as incorrect, where they disagreed, and why. This discussion pushes them to articulate their thinking, defend their reasoning, and consider alternative perspectives. It turns the AI-generated solution into a springboard for collaborative sense-making. Research shows that this kind of peer dialogue strengthens both conceptual understanding and communication skills. Students aren't just checking answers, they are building reasoning together. Finally, groups share their revised solutions with the whole class. They explain where ChatGPT's reasoning was strong, where it needed correction, and how they improved it. This public reflection helps students organize their ideas, communicate clearly, and justify their thinking. It also normalizes productive struggle. Students see that errors, including AI's errors, are opportunities to learn. By the end of this cycle, students haven't just solved a problem. They've analyzed it, debated it, refined it, and taught it, building confidence and deeper mathematical reasoning. Of course, using AI in learning also brings real risks. Students may become over-reliant, letting AI think for them, and skipping the productive struggle that builds deep understanding. There's also the issue of AI errors, incorrect steps, flawed logic, or oversimplified explanations that students might trust too easily. Another challenge is surface-level engagement. If students use AI only to speed up homework, they gain accuracy, but lose meaningful learning. And finally, these tools can widen equity gaps if some students know how to use AI effectively while others don't. This means pedagogy matters more than ever. We must design structures that promote questioning, verification, and student agency so AI supports learning without replacing it. To use AI effectively, we need clear design principles. First, treat AI as a scaffold, not a solver. Let it reduce unnecessary load, but keep the core thinking with the student. Second, align tasks with Bloom's taxonomy. AI can support lower-level tasks like explanation or rephrasing, while students take on analysis, critique, and creation. Third, embed AI in collaborative learning. Activities like group error analysis or collective problem redesign help students internalize concepts, not just consume AI output. And finally, teach AI literacy, how to prompt, question, verify, and reflect. These habits ensure students stay in control of the learning process and use AI strategically, not passively.